Okay, today we're going to talk about artificial intelligence and the role of synthetic data. And I'm very pleased to say I'm joined by two people that know all about this. I am joined by Rana Kaliouby, who is the CEO of Affectiva, a software company that builds artificial intelligence and helps to understand human emotions and cognitive states and activities and the objects people use by analyzing facial and vocal expressions. And by Yashar Behzadi, who is the CEO at Synthesis.AI, a company that brings together novel generative AI models and evolving technologies from the CGI world to generate pixel perfect labeled images to help others build better AI models. It's so nice to have you with me today.
It's a pleasure.
Yes.
So Rana, Affectiva is doing some super exciting stuff. Maybe you can give us a brief overview of what you do.
Yeah, so we spun out of MIT Media Lab a number of years ago, and we are on a mission to humanize technology by essentially building AI that can understand humans and that interacts with humans just the way we do with one another. And so we leverage machine learning, computer vision, and tons of data to build these models that can understand your emotions, your cognitive states, your behaviors, your activities. And we're focused on a number of markets. One of them is the automotive industry, where we are building in-cabin sensing solutions. We want the car to understand if you're tired, if you're distracted, if you're paying attention or not, and then the car can interact with you in real time to ensure that, you know, our roads are safer. So that's one area of application of the technology. A lot of the models we build, a lot of the machine learning algorithms we build are very data hungry. And we spend a lot of our mind share and we invest a ton in acquiring data. And so, yeah, investing in synthetic data is the path forward here. And we've been partnering with Synthesis.AI over the last year to bring more diverse data at scale, faster, cheaper, into our organization and allow us to bring our technology to market faster.
Great. And Yashar, tell us a little bit more about what Synthesis.AI is doing.
Absolutely. First of all, thanks again for having me on the show. So at Synthesis, we're building an on-demand image generation platform to really power folks like Rana and her organization to build more capable models. And maybe just as a kind of reference point, I'll talk about how systems are built today and then kind of what synthetic data really does change in terms of that paradigm. So in computer vision, the way we build these AI systems today is by first building some hardware, acquiring a lot of data, handing it off to humans to then annotate the things in the image that you're most interested in. So in Rana's example for driver state assessment, that would traditionally be done by instrumenting cars with lots of different camera systems and driving around to hopefully capture the events that you're interested in. Each of those images gets hand labeled by someone for facial position, segmentation, gaze, other things that you may be interested in. And then the systems are trained with modern deep learning systems. At the end of this whole long protracted process, you finally understand what your system can do. And you identify gaps and you go back out and you collect more data. Right. So it's a very long process, it's a very expensive process. And as you can tell, it's a little bit inverted with respect to other engineering disciplines in which you have great design tools and simulation tools to kind of really help inform how you build these systems. So with synthetic data, we're able to kind of invert this paradigm and really change how this is done. So what we've done for Rana and team is create a model of the car interior and place synthetic individuals. So borrowing heavily from CGI, visual effects, things we've seen in the movies, generations of innovation happening to create amazing photorealistic images. We supercharge those with generative AI models, and now we have the ability to create thousands of unique individuals spanning ethnicity and gender and age and BMI, all the attributes you want to be robust against within the car cabin across various camera angles and imaging modalities and situations. And once you have that set up, you're generating hundreds of thousands, if not millions of data points instantly. And because everything is created in this 3D world, you have perfect understanding of every pixel in the frame. So beyond the traditional labels that you may be interested in, now you can get depth, you can get material properties, you can get 3D position, right? So you have this shift in which you have on-demand data generation, expanded labels with high accuracy, and now you're in a very iterative process of building models, but ultimately we're in the business of trying to enable folks around it to, build better and better models.
Yeah, I love this because lots of AI models have relied on traditional data sets of labeled faces, for example, and they obviously have huge limitations.
Absolutely.
And they also quite often have biases. We know that there isn't the representation of Black people in some of those databases and other ethnic minorities and so on. So I guess this is a huge advantage of having synthetic data, that you can create a less biased, a completely representative sample size to then train your algorithms, right?
Yeah, absolutely. I mean, and some of the kind of the pillars that we've kind of worked across for what we're trying to do is to make fairer AI systems, right? By being able to declare the distributions of data, you ensure that you're representing all the different classes you're interested in. So whether it's ethnicity or gender or BMI or age, for instance, you're able to create well-balanced kind of data sets. That's the first piece. Second piece, you can do it in a very privacy compliant way. Synthetic data, you don't have to worry about breaching consumer rights, and with GDPR and increasing regulation, that's very important. And this also then enables folks, it kind of democratizes access. So you have smaller companies that are more innovative can now compete and win in some of these verticals. So that's always been kind of fundamentally about what's driven us to kind of build these types of systems. And then maybe on the bias side, as you point out, ethnicity is obviously top of mind for how these systems are built. But also, you want these systems to be robust against situations as well, right? So if you don't have what representative, lighting, right? You don't have good data around that, or head pose, or mask wearing, right? Things that change, overnight potentially with how the images are viewed, then your systems aren't going to work robustly.
Very good. So what do you see as some of the advantages, Rana, of using synthetic data for your own purposes?
I mean, one of the things that we really like about our partnership with Synthesis and the team there is your commitment, Yashar, to diversity and to mitigating algorithmic and data bias. And that's something we care deeply about. And we've invested a lot of our mind share to ensure that our data sets, both the training data set and the validation data set, is diverse along these factors, ethnicity, gender, age, but even things like wearing glasses and sunglasses and baseball caps and having beards and wearing the hijab. Like, all of these things actually matter. And it's really hard to get such diverse data sets. So I see one of the key advantages is being able to be very, very intentional about this diversity, and mitigating the algorithmic bias that is, comes as a result of non-diverse data sets. And then the power of iteration, the speed of iteration is just amazing. I mean, we've spent over the last couple of years, we do a lot of work around drowsiness detection of drivers. And there are at least 4 levels of drowsiness that we're interested in, everything from awake to completely asleep. So the way we do this before Yashar and his team came along was essentially literally bring people in overnight. So they come into the office or our labs awake, and then we put them in a car simulator overnight for 6 or so hours. And by the end of that experience, they're pretty tired and asleep, or falling asleep. But you want that. I mean, that's so hard to scale. It's so hard. It's so slow. It's such a slow process. But with synthetic data, we can automate that. We can scale that. We can generalize that very quickly. We can get, for the same person, we can quickly simulate all of these different stages of drowsiness. We can change the camera angle, which is a key component in the automotive industry. We're seeing a shift from these camera positions being in the steering wheel column to the rear view mirror, so that it gets a full view of the cabin, which is a very different point of view of the face. Now we can do that very quickly with synthetic data. So I think it's a key. Data has always been one of our key competitive advantages, but by augmenting our training data to include synthetic data, that gives us more of a stronger competitive advantage, in my opinion.
Yeah, I love this, because we're using AI machine learning to generate images that I then use to make better AI machine learning models. So it's pretty cool stuff. So Yashar, how does the technology work behind all of this? How do you create synthetic images?
Yeah, absolutely. I mean, we're borrowing heavily from kind of the Hollywood industry and CGI, visual effects, and gaming. I mean, there's just been tremendous innovation over the last years, and we're all kind of seeing it on the screen, right? So we kind of appreciate it in that regard. So we're using fundamentally cinematic pipelines to create very diverse photorealistic images. Now we supercharge that a little bit with using generative AI models, and things like GANs and things are very useful to create. We actually use them to create assets, and in our language, assets are kind of 3D structures. So a face, you can think of it as a 3D structure, just like you can of any other object. It's a little more complicated, but similar kind of feature set. And then there are textures that lay on top of that. So we use AI to kind of create a diverse set of those elements, and then we use our kind of CGI pipelines to manipulate the image. So for the use cases that we're talking about here, it's about first creating variable car interiors, and then putting individuals in those situations. And because we have full control, we can easily change head pose, expression, gaze angle.
Mm-hmm.
We can add just additional confounds, glasses, different tints on the glasses, which makes tracking the eyes more or less difficult depending on use cases, right? Facial, hair, makeup, obviously just hair, mask, accessories, and then the lighting. So you have all these different layers that you can parameterize and combinatorially just create tremendous amounts of diversity. Now in practice, it's a very iterative process, like Rana mentioned. One of the things we did with Rana and team initially was, let's answer our first question, which is, where do we put the camera and what kind of camera should we have, right? Because you have choices. Is it RGB? Is it near infrared? Is it time of flight? Is it a combination of those things, right? It's a very hard question to answer in the real world without having all of those systems and making sure you oversample to ensure you have the data in case you forgot, you want to test this position you didn't have, because then you have to go back to the beginning and start over. So we did that. And then based on that, we said, okay, well, let's think about how to make our systems more robust with head pose and lighting. So then you can create additional data. And it becomes this very iterative process of really testing and streamlining your models to make sure the most robust systems.
One of the key questions we asked at the beginning of our collaboration was essentially, we'll never do away with real data. It will always be an important component of both our training set and our validation set. In fact, in the automotive industry in particular, I don't think the automakers are totally bought into using synthetic data to test these systems yet. We'll get there. But for now, our validation data set is entirely real world data. But for the training data set, one of the key questions is, what percentage of our models can be trained on synthetic data versus real data? And we tried different combinations, different weightings, right? Obviously, we want more synthetic data in there. But the question is, how does that affect the accuracy and the robustness of the models? And this is where the iteration came in, right? And we will continue to do that. I mean, we have a whole roadmap of things we want to try out together. This is just the beginning.
So some of the things Affectiva is doing is obviously is around detecting people's emotions, which is, I guess even 5 or 10 years ago, I would have said this is something that AI will probably never be able to do, become truly emotionally intelligent. So how do you go about training AIs to recognize people's emotions?
Yeah, and it is a complex undertaking. I mean, as you know, we take a very thoughtful and scientific approach to the process. It's very simple and easy to build a smile classifier that's actually kind of straightforward, but that's not really that's not what we're trying to do. We're acknowledging that humans are very complex. We're interested in the nuanced cognitive and emotional states. So things like frustration or confusion or fatigue, right? Like, what does fatigue look like? Distraction, when you're doing this as you're driving your car. And if we can combine that with some information, oh yeah, you have a phone in your hand, or like object detection, augmenting all of this to detect activities and behaviors, it becomes really powerful. So the goal is to combine these multiple modalities to get a very holistic understanding of what the person's state is, and then have the technology or the car or the device respond in real time. So I still think there's a lot of work to do, which I think is exciting. It makes this tech category of human perception AI and emotion AI really fascinating. And especially in the last year with the pandemic and all of us having to be working remotely and spending a lot of time on video conferencing platforms, I think that opens up whole new layer of innovation on how we can incorporate these signals into how we connect and communicate with one another. So I just think there's a lot of exciting stuff coming in the pipeline.
Absolutely. So Yashar, is it just images of faces that you're generating at the moment, or are you going beyond that at some point?
No, our ambitions are to create a full solution for the long tail of computer vision. Right, over time we'll get there. We take a very kind of vertical specific approach. So we create APIs for specific verticals, for specific data types. That serves a lot of people within kind of that need. So we have a face API as our first product that we've announced, obviously supporting things that Rana is speaking about, but it's used by smartphone manufacturers, smart assistant developers, teleconferencing companies. There's a lot of use cases just for that. But we're building out many more. So we have a number of initiatives around full body, gesture, movement, behavior, activities, in different contexts. So people in context is kind of an organizing theme for us in the next year. So one context being the car, obviously another context being inside the home, inside your place of work, inside retail, out in public areas, the street. So, and all of these feed into different kind of use cases around smart assistants, smart homes, enterprise access. Excuse me?
Social robotics.
Yeah, social robotics. And then we have robotics initiatives. We co-published with Google on some robotics work that we're doing. So, and so on and so forth. So I think we're going to be, over time, in the next 3 to 5 years, you're going to see just a huge expansion of synthetic data applied to various different kind of domains. And we see a paradigm in which synthetic data is used just like CAD models are used for mechanical design or aeronautical design or any other kind of engineering discipline, in which you can, with high fidelity, understand and build systems and know that they're going to work with certain regards, because you have confidence now in those kind of simulation tools, and then build things much more efficiently.
So what other companies might benefit from using machine-generated face data?
Sure. Yeah. So, I mean, if you think about kind of the systems in your life today, and what you use, a lot of them are centered around the face and kind of that thing. So your smartphone, you have to unlock your smartphone. You take pictures with your smartphone, and there's a lot of AI used to kind of enhance the images. So smartphone manufacturers, we work with 3 of the biggest smartphone manufacturers to build both of those systems for them, and make those things more robust. Teleconferencing, obviously we're all spending a lot of time in these virtual platforms. A lot of innovation happening in that space. Some of the things Rana spoke to are kind of future looking, but people are focused on how do you overlay this with a gaze estimation and emotion sensing, and becomes very relevant in telemedicine and some other areas, but more basic things as well, like how do you create better backgrounds? Everybody knows kind of Zoom backgrounds kind of suck. So how do you fix that? Well, you just need a lot of better kind of data to build segmentation models. And people are also thinking about AI to optimize the image quality and use bandwidth more efficiently. All right, so teleconferencing is an interesting space. And then finally, I think a big growing area which intersects with Rana and what stuff she's doing is smart assistants, right? And if you think of the next generation of Amazon Alexa and all these kind of competitive products in that space, they're all going to want to interface with you and understand the person in that interaction model. And every future instantiation of AI, right, if you think of from a sci-fi movie perspective, is a person and an AI system interacting. And the only way that happens is that the AI system understands the individual and understands evoked responses.
Very good. So Rana, beyond the car companies that are using some of the technology that you are developing, where else, what other industries are you working with, or what other industries could really benefit from your emotional AI?
Yeah, there's one of our other business units is all about understanding how audiences emotionally engage with content. So we're spending hours and hours of our day online engaging with content, video content. So we are able to capture in real time the moment by moment responses of this engagement. Are people interested? Are they engaged? Are they bored to death? And we can use that information to drive content creation, media spend behind these content, brands, etc. So that's one use case, and we partner with 1/3 of the Fortune 500 companies in 90 countries around the world to use who are using this technology every single day. Beyond that, I'm super excited about the applications in kind of social robotics, conversational interfaces, and maybe even the Internet of Things. I mean, one of my favorite examples is, imagine if you have a smart fridge and it knows that you are stressed because it has a mood chip, right? And it says, you know what, you're about to have your fifth tub of ice cream. I'm not going to let you do that. And it locks down, right? Well, that's going to require human perception AI and human, and emotion AI. It needs to understand your state. So I would imagine it would require a lot of synthetic data training. That would be fun to do, like a lot of ice cream eating.
Very good. So what would you see as some of the maybe the ethical challenges around all of this? Because with all technology, you can use it for good and maybe for not so good things. How do we manage this, especially when it comes to synthetic data? I guess there's always a danger that you can create deep fakes that are used for not so good purposes. How do you manage that aspect?
Yeah, so maybe speak to the technology a little bit. So, we build training sets for companies to build models, right? So we don't build deep fakes, we don't build content, that's not what we do in our space. But there are similar technologies that people are using, I guess, to kind of create media, right? And in other contexts. And I think ultimately, that's with any technology, as you mentioned, there's going to be kind of two sides of the utilization, and it comes down to the ethical principles of the companies that are operating in the space. And, for us, we're very focused on creating fairer systems, better systems in a privacy compliant way, reducing bias, and there are a number of use cases we just say no to, right? We've been approached for a number of things that require, facial surveillance systems and, kind of government uses, and we just say no. And I think more and more companies are going to have to do that to kind of draw that line on the ethical bounds.
Very good. Yeah. I guess the same for you, Rana, that people that might not be familiar with the whole space of AI and some of the current advances would feel slightly freaked out that you now have a computer or a fridge that understands your mood or your emotions.
Yeah, and we have very strong core values around that. And again, it's one reason why I just love partnering with Synthesis.AI and the team there. I really do feel like there's a meeting of the minds when it comes to these core values. So we don't entertain any business where people are not giving their explicit consent and opt-in. So that has meant that there are industries where we just do not engage, like surveillance, security, lie detection. We've been approached over the last 10 years by many organizations and governments who wanted to pivot our technology kind of for these use cases. And we basically say no. And we've turned millions and millions of dollars of potential funding and revenue because we do not feel that that is the right use of this technology at this moment in time. So that's kind of one area. The other area is just to be very thoughtful about what value am I getting in return for sharing this information as a user, right? And we think a lot about that. Like in the automotive use case, well, it's going to help me be safer on the road. And I think that's a very strong value proposition for me as a consumer. But it's an evolving conversation. I think it's incumbent on CEOs and leaders like Yashar and myself to advocate for these strong core values and be vocal about it and bring in investors that believe in these core values, because that's the only way we get there as an industry, as a tech industry.
Very good. So let's look into the future. What's on the horizon for both of you? Maybe Yashar, where do you want to take this? What do you see happening in the future? What excites you? What are your hopes and predictions? And then we go to Rana and do the same.
Yeah, no, absolutely. And as I mentioned, we're looking to support the long tail of computer vision. And if you kind of forward, a number of years and you have a high fidelity representation essentially of the real world, right? Of kind of different people in different contexts, and you can mimic behaviors and put in things like consumer planning and behavior, and you can start really building some really interesting systems and understanding more complex behavior of social interaction, of environmental interaction, and it ultimately leads to kind of new and better models. And also synthetic data is a democratizing force, right? Because you can log in and start creating millions of images and start training your systems. That really changes who can access and who can benefit from and who can contribute to kind of the AI space. And I think that'll break down some walls that have existed where the larger tech companies have built these data moats and kind of have leveraged their capabilities to ultimately sell you more advertising most of the time, right? And I think there's so many better benefits out there, and it'll unblock those use cases.
Very good. Is it beyond still images? Are you thinking about
absolutely
animated avatars?
Yeah, absolutely. Think of basically a replication of the real world when you have 3D environments, interactive agents doing things. There are a number of techniques that you can leverage, like reinforcement learning or imitation learning, to create these more intelligent agents that then can have goal setting and other things that will be leveraged for understanding more complex behaviors.
Very good. Rana, what are your future prediction and future hopes and directions for Affectiva?
Yeah, I just want to start with the automotive industry, because I think there's a lot more, again, we can do with Yashar and his team in that space. So we're moving beyond just looking at the face, and we're doing body key point tracking to understand activities like, are you eating? Are you drinking? If you're a backseat passenger, like what activities are you engaged in, and who else are you engaged in? Because as you imagine, kind of the evolution of what a mobility experience looks like, and as we start to see robo-taxis and semi-autonomous vehicles on the road, the mobility experience is going to become very personalized and almost reimagined altogether. So we want to be able to detect all of these behaviors. We also just wrapped up a data collection exercise where we literally brought on dog owners, pet owners, to our lab, to our vehicles, and we had all sorts of dogs inside the car, and we had the dogs do all sorts of things. Well, Yashar, you just generate like hundreds of thousands of examples of pets in a vehicle and we'll be done. So here you go.
Yeah, absolutely.
Add it to your backlog of feature requests. So that's another one. And then outside of computer vision, I think there's an opportunity in audio as well. Like we think of it as a multimodal solution eventually. 90% of how people communicate is nonverbal, and it's split equally between kind of your face and your body gestures, but also your vocal intonations. How fast are you speaking? How much energy is in your voice? And that's a whole new world where, again, synthetic data can be very powerful.
Fascinating. Thank you so much for joining me today. That was super exciting, and I can't wait for our next conversation.
Thank you for having us.
Thank you. Pleasure.